indirect. So let's pretend that we didn't do any of that work. I also told you accidentally that we were going to actually start on the area calculations. I fibbed. We're going to start and do the indirect method. So pretend that we didn't do all the math that we just did. Pretend that somebody said, oh, here's all the coordinates for those points that you just figured out. So now we know the northing and the easting of each one of these points. We know the northing and easting of the point northeast, the point number 2, and the point 3. So I've written those over here on the board. Okay, all I did was copy them from before. Now, in the indirect method, it says, all right, I need you to figure out the adjusted latitude and the adjusted departure. I need to figure out what this actual departure and latitude is. But you don't have any of the azimuths or anything like that. You just have X and Y, or northing and easting, for each one of the points. So how do we do that? We do it in reverse. So, for example, if we know the northing of point 2 and we know the northing of point 1, then all we have to do is subtract the northings to get the latitude. Same with the departure. If we know the easting of point 1 and the easting of point 2, we just have to subtract the 2 to get the departure, right? Now, here's the other thing, is knowing when one's a negative and one's a positive. You're always starting with the second point when you're writing this. Notice how I've written it. It's actually 1, 5, 2, 3. So it's using point 2 subtracting from point 1. And that will give me a negative value. Okay? And it's the same on the eastings. I'm subtracting from point 2 to point 1. And you keep doing that going down. But I'm not going to sit here and do all the math. We did it before. I'm just going to use our adjusted latitudes and departures that we've already calculated. Now, I'm pretending that we did all the math because I have the values. But all you're doing is subtracting each one of these to get the adjusted latitude and the adjusted departure. When you do this for your project, once you've done the northing and eastings, you can just take them from the plan sheet that you just did. But the indirect method would be if you didn't have to do all that math previously and you only had northing and eastings for each of your points. Okay? So the whole purpose of this part of it is okay, now we've found the northing and easting. That's all well and good. We know exactly where our property is located. Now we've got to create a plat. The plat is the legal description of what the piece of property is talking about. Okay? So I own, these are my 3 corners of my property. So now I have to tell you, start at the northing easting, go south so many feet or whatever, a bearing of whatever degree and whatever length. Since we manipulated and forced this thing to be 180 degrees and forced this thing to close, do you think the lengths and the azimuths we calculated at the very beginning of class are going to be the same? No, they're not. They're not. Are they going to be huge different? Let's hope not. But they're not going to be that different from what we originally calculated, but they are different because we forced this to close. So, whoopsie. I'm not very graceful. Sorry, guys. Just don't poke my eyes out. That'd be great. Okay. So I'm just going to take from my calculations from before my latitudes and my departures. So I'm just going to write them down. So I've got 57.181, 69.508, and my green ones is 85.994 and negative 30.372. Now, the length is what we have to figure out. Now, how are we going to find the length? When we drew this, and I'll just drag it back, I'm no problem. So I don't trip over it, and it's going to help me. Since we drew these, how do I find the length of the line from the northeast to 2? I've got my departures and I've got my latitudes. Remember what I drew was a right triangle. Exactly. A squared plus B squared equals C squared. So there's A's and B's. And this is why I harped on before about your negatives. Here's the thing. When you square a negative, it's going to become a positive. So if you don't even feel like putting that negative sign in your formula, don't even bother with trying to put all the parentheses. Just, you know in your mind it's going to be positive anyway. Just let it go. So basically, you're going to take the square root. So the square root of, and I'm going to write the negative in here because I don't want anybody to think that I just arbitrarily dropped it off, but I'm going to put it inside the parentheses. So I'm going to go negative 126.689 squared plus negative 55.622 squared, and that's going to give me 138.362. Now, how far off was that from the original? It was originally 138.345. We're in the second decimal place here. So not that much, but it's still wrong, technically, so we're fixing it. So the next one would be the square root of 57.181 squared plus 85.994 squared. That's going to give me 103.270. The original one was 103.285. Still not much difference. The next one is going to be the square root of, I'll write this in order, 69.508 squared plus a negative 30, notice I'm putting it in the parentheses, 372 squared. Okay? Now, put the square out here. Now, that gives me a 75.854, and it was originally 75.855. So these aren't much off, okay? Now, the next part, the actual bearing. Remember what a bearing is. Bearings are northeast, southeast, northwest, southwest, and they can't be any greater than what? 90 degrees. So you're not going to get 120 degrees southeast. No, it is going to be in the southeast, yes, but it's not going to be greater than 90 degrees. Now, back to my picture. Can you see it? We are going from northeast to number 2. Now, I harp on this because it's always a visual thing. So if I said that if I'm going from northeast to 2, what direction am I going? What direction am I traveling?
Southwest.
I'm going southwest. So when I look at the bearing, the equation for the bearing is, I'm not going to make you turn. So the bearing can actually be found using tangent. So inverse tangent of the departures over the latitudes. Now, here's the thing. For the math people in the class, tangent is what? Opposite. Adjacent, right? The opposite over adjacent. Guess what? It doesn't fly here because we're actually using the opposite direction. If you look at it, so the tangent of, depending, I had one guy, instead of using azimuth, he used all his interior angles. So opposite should be latitude and adjacent should be the departure. Sometimes it doesn't work. So just be aware that you're using, when you're doing the bearings, you're finding it off of this line here, not this angle here. Okay? You're not coming off the east-west line. You're actually coming off the north-south line. So the opposite is the departure, and the adjacent is the latitude. So you have to be aware what angle I'm looking at. I'm not looking at this angle here. I'm always looking at the angle off the north-south line. Just for the math people be like, that doesn't make, because when I first did it, I was using my math person lens, and I'm like, I don't get it. I just don't get it. And then finally, when I drew up and understood that bearings were only off the north-south line, it made more sense for me. So that's just an FYI. Now, here's the thing. It's just if you use the equations, you're golden. Just follow along the equations. But it's nice to know what the equations are supposed to be doing. All right. So I'm going to write tangent inverse of negative 55.622 over negative 126.689. Now, the negatives don't really matter in this equation. except for it's telling me that it's west and south. I can't write. And south. Okay? So when I do the math, our calculators, and the reason I gave myself 2 columns, the calculator actually spits out 23.70357076. Now, the reason why I'm putting so many decimal places in this is because the seconds, if you shorten this to only 3 decimal places, you're going to lose out on a lot of seconds and even possibly, and I don't remember if it's minutes, but you do get screwed up on your seconds. It's not as accurate. So use all your decimal places when you use your calculator, okay? Or the Excel sheet. So, is that a question? Okay. So the bearing is actually south 23 degrees, 42 minutes, 13 seconds west. Okay? Now, from 2 to 3, I'm going from, that's okay? You sure? Yeah. Okay. I don't want to trip. So going from 2 to 3, I'm going which direction? Going northeast, right? So when I look at this, and I can tell that I'm going northeast just by its positive. Okay? So I write tan inverse of 85.994 over 57.181. I'm going north and I'm going east, just based on my latitudes and my departures. So that's going to give me 56.5637840.843, and that corresponds to north 56 degrees, 22 minutes, 42 seconds east. Okay? So that gives me the new bearing on that line. So the last one, I'm going from number 3 back to northeast. Now, which direction am I going? Northwest. I'm going northwest. So my bearing is tan inverse of negative 30.372 over 69.508, and that's west and north. And I only write these to make sure I remember what the bearing is. So that's 23.60325422, and that's going to give me a north 23 degrees, 36 minutes, and 12 seconds west. All right? Now, when surveyors write the legal description, they almost always write in bearings. I have not seen a legal description in an azimuth. However, you're working with engineers in addition to this. And engineers, we like azimuths. We don't like bearings. We're funny that way. They're, for whatever reason, they go in our calculator. The first calculator I ever owned didn't have degrees, minutes, and seconds in it. So I ended up having to convert all of them by hand before using it. So if I want to figure out the azimuth of the first one, I'm going to draw myself a little picture. Okay, it's going to be a big picture. I am going from northeast down to point 2. This angle here, because we said we're north, south, west, east. We said we're going 23 southwest, right? That's this angle here. 23 degrees, 42 and 13 seconds. That's this angle here. What is this angle here? It's 180 degrees. This is 180 degrees, right? So if I take 180 plus the 23, that's going to give me my azimuth of this line. So I'm going to take 180 degrees plus 23, 42, 13, and I'm going to get 203, 41, 55. If we look at our original, I'm sorry, that I wrote it down on. I can't read. Somebody needed to stop me. I just read off the sheet of my paper and I'm like, oh, that's not right. we get 203 degrees, 42 minutes, and 13 seconds. The original value that we had from the azimuth we calculated over there was 203 degrees, 41 minutes, and 55 seconds. Not a lot different, right? Now, if I'm going from, let me erase this. Now I've got my axis sitting here, and I've got point 3 over here. So now I'm going in this direction, right? And it said that this bearing from, oh, that's bad. Okay, not to scale. Looks like 80 degrees and I've got 56. Okay, let me erase that. So I'm going from point 2, here is my axis, and it's 56 degrees, 42 minutes. So there's about a 45. So here's my 56. And here's point 3 over here. So this angle here, since it's in the northeast, this angle here is 56 degrees, 22, 42, right? So when you're in the northeast quadrant, what is your azimuth?
Same as the boundary.
Same. So all I have to do is write 56, 22, 42. So that's my azimuth. Now, lastly, I'm going from a point over here at number 3 back to the northeast. I'm sorry, northwest. North and west. And it said that it was 23 degrees, 36. So 23 degrees, 36 minutes, 12 seconds. Now, what is this angle here?
360.
So I'm going to take 360 degrees and I'm going to subtract 23, 36, 12 from it. And I'm going to get 336, 24, 20. Okay? I keep writing the original down. I am so sorry, people. I can't read my own writing. 336, 23, 48. And the original was 336, 24, 20. So there's not a lot of difference, but now we know that we're 100% accurate. Okay? So we're going to pause here. Now we're actually going to go and do the area. All right? So we're good to go.